Hello everyone. In this video, we are going to talk about the chain rule of differentiation. So before that, let's talk a little bit about what composite functions are. So composite functions are the name suggests, it's the composition of the functions or function inside a function that is usually represented as f of x as any general function and g of x is also any general function. So f of gx will be a composition of f and g, which is also called a composite function. Another name for this composition functions, let's write it over here. So another name for the composition function will be nested functions, or it is often called function inside a function. So function inside a function. This is what is the other some terms with which composite functions uh, is called. Now let's look at a couple of examples of what composite functions look like. So one of a simple example of composite functions is cos of x square. Now, let's try to divide this in two parts, in which one is the outer function and one is the inner function. So clearly, the inner function, by our intuition, we can tell that the inner function is x square, and the outer function is cos of, it's the cosine. So if we now write this as fx, let's say cos x, and this as gx, and if we want to write f of gx as in the composition, so we replace the x in fx, which is over here, by gx, and gx is nothing but x square. So this is the composition of f and g. Some other couple of examples of the composition functions can be, uh, it can be ln cos x. This is also an example. One is sine of ln x. One is e raised to the power sine x. Then it can be tan of, let's say, sine inverse x, and etc. These are all the part of the composite functions where we have inner as well as the outer function. Now let's talk about the chain rule. In the blog, we talked a lot about how to do the chain rule, and how we can treat the chain rule uh, as destruction, where we start from the outermost, we keep destroying, and we went inside to differentiate it or to destroy it completely. So we'll do a couple of examples in this video. The first example is we got to differentiate sine of x raised to the power 4. So let's do it systematically. Dy over dx using the chain rule, of course. First, we differentiate the outermost part, which is sine, and differentiation of sine is cos. So we have cos, and x raised to the power 4 remains as it is, because we just learned a rule. In the last part of the blog, you will see that we have written that n raised to the power n raised to, n times, or let's say, uh, stuff raised to the power n is n times stuff raised to the power n minus 1 and something. So we always treat that inside term as a general part, which is stuff. So for me, right now, the stuff is x raised to the power 4. So how will I read it when I will differentiate? When I differentiate, I will say that sine of stuff, differentiation is cos of that stuff, and then we go inside, and then we differentiate the stuff. This is what chain rule is. So this is cos x raised to the power 4. Differentiation of x raised to the power 4 will be 4x cubed. So this comes out as 4x cubed cos x raised to the power 4. This is the answer to this question. Let's talk about question number 2. So question number 2 says that we have to differentiate cos of 1 over x. Again, d over dx would be differentiation of cos of something would be negative sine of something, and then we go inside and we differentiate the something, which is 1 over x. So this is sine of 1, negative sine of 1 over x, and negative sine of 1 over x remains as it is. Differentiation of 1 over x can be written as x raised to the power minus 1. So this is nothing but negative sine of 1 over x, and here we got to use the power rule. So minus 1 comes down, we have x raised to the power minus 2. So this finally gets simplified to negative, and negative becomes positive. So we have sine of a sine of 1 over x over x squared. So this is the final answer. Let's talk about another example. We have to differentiate y is equal to natural log of 2x square plus 1. So the differentiation for this would be dy over dx is, again we got to use the chain rule. So first we differentiate ln of something. Ln of something is 1 over something. So here we have differentiated natural log, then we go inside and we differentiate 2x square plus 1. So 1 over 2x square plus 1 remains as it is. Differentiation of 2x square will be, 2 is a constant, so it comes outside. Differentiation of x square using the chain rule is 2x, and differentiation of 1 is just 0 because that's a constant. So this comes out as 4x over 2x square plus 1. This is the answer for this question. Talk about the next one. We have example, this would be example 4. Let's talk about example 4. We have e raised to the power, y is e raised to the power 4x cube plus 1. Again, chain rule. So we have e raised to the power something, differentiation of e raised to the power something. Then using the chain rule, we go d over dx of the power, which is 4x cube plus 1. So this is e raised to the power 4x cube plus 1 remains as it is. This 4 comes outside. Differentiation of x cube is 3x square, and differentiation of 1 is 0, so we won't write that. So this comes out finally as 12x square e raised to the power 4x cube plus 1. This is the final answer. Uh, let's talk about the next one. So we have example 5. We have to differentiate sine inverse. This is an inverse trigonometry now, trigonometric function, 4x plus 1. So dy over dx is sine inverse of something, differentiation is 1 over square root of 1 minus that something square, which is 4x plus 1 whole square. Then we go inside and we differentiate 4x plus 1. Differentiation of 4x is 4 and differentiation of 1 is 0 over the square root. We can open the brackets, open the squares. So we have, using the identity of a plus b whole square, we have 16x square plus 1 plus 8x. So this comes out as this 1 and minus 1 got cancelled, and what are we left with is minus of 16x square minus 8x. So this is the final answer for this question. Let's talk about the next one. So we have example 6 now. This would be an algebraic expression. So x square plus 2x plus 3 whole raised to the power 5. So dy over dx using the power chain rule. First of all, whenever there is a power outside, it's actually called power chain rule. So first we break this power. So power comes down and base raised to the power 5 minus 1. This is what we get. Then we go inside and we differentiate x square plus 2x plus 3 using the chain rule. So this comes out as 5 x square plus 2x plus 3 raised to the power, this is 4, then this differentiation of x square is 2x, of 2x is 2, of 3 is 0. So this finally comes out as 1, 2 can be taken out, and 5 times 2 is 10. So we have 10 times x plus 1, x square plus 2x plus 3 raised to the power 4. So this is the final answer. Let's talk about the next one. This one says that y is e raised to the power x. This is interesting. So when we differentiate, the e raised to the power something is e raised to the power something times d over dx of power. Now power is e raised to the power x. E raised to the power x is as it is. Differentiation of e raised to the power x is just e raised to the power x. So the final answer is e raised to the power x times e raised to the power x. So this is the final answer. Let's talk about the next one. So we have example number 8. This one says that e raised to the power 4 raised to the power x square. We need to find the derivative. So when we do the derivative, we have e raised to the power something as e raised to the power something times d over dx of power, which is 4 raised to the power x square. So this is e raised to the power 4 raised to the power x square times a raised to the power something is a raised to the power something natural log of base, and then we go on the power using the chain rule, and then we differentiate the power, which is x square. Differentiation of x square is 2x, so finally this comes out as 2x ln 4 raised to the power x square e raised to the power 4 raised to the power x square. So this is the final answer for this one. Let's talk about the last one, which will be example 9. This is actually an accumulation of all the terms. So we have y as e raised to the power x cube plus cos of natural log of x plus x square plus 4 whole cube plus natural log of 4x square plus 7. We need to find a derivative in this case. So the derivative for this would be dy over dx is equal to differentiation of e raised to the power something is e raised to the power something times d over dx of power, which is x cube. Differentiation of cos is minus sign of something, and then we go inside and we differentiate ln x using the chain rule. For the power, whenever we have a power, we apply the power chain rule. So power comes down, power decreases by 1, which is 2, and then we go inside and we differentiate x square plus 4. Then differentiation of ln of something is 1 over something. We go inside and we differentiate 4x square plus 7. So this is what we are getting. Now let's differentiate this further. So from here, this term remains as it is. Differentiation of x cube is 3x square. Here we have negative sign, ln x remains as it is. Differentiation of ln x is 1 over x plus 3x square plus 4 whole square. Differentiation of x square plus 4 is 2x plus 4x square 4x square plus 7 is just 0. 4x square will be 4 times 2x, which is 8x over 4x square plus 7. So this may be simplified further, but we are interested in the chain rule as of now. So this is how the chain rule is applied to this one. So these are a couple of examples which might help you to understand the concept of chain rule better, and the theory is all included in the blog.